In the figure shown, when a critical mass is reached in the cosmological constant/gravity force in exploding supernova or white dwarfs, there seems to be a mostly horizontal explosion in mass and energy. This is comparable to what happens at the double slit experiment. When you narrow down the light source, it reaches a critical point, then changes behavior from acting like a particle into exhibiting characteristics like a wave. It has a reflection on the wall behind the two slits. Similarly, in a supernova, gravity reaches a critical point compared to mass, and there is an inflection of the force which creates a large burst of energy and thus transmutes into exhibiting wave-like behavior. One could also describe this as a burst of cosmological constant energy that would resemble the picture of the figure. If you juxtapose figure 1 and figure 6, there seems to be elementary patterns that unite them from the very small to the very big. Waves are particles, and particles are waves. In the figure of the traditional hydrogen atom, this type of atom could achieve wave-particle duality when squeezed down to a critical point, mimicking a particle/vibration that we could call a wave photon. Its internal constructs would exhibit both wave-particle duality-like formations of energy and mass. From a vibrational perspective, the cosmological constant and gravitational force in string theory could operate in a combination of the figures shown. This is internal containment, and in this figure is a force moving externally. They could share vibrational strands with some sort of energy transmission, defining and connecting the force lambda/g, making it a reciprocal of each other. Obviously, there are different pictorial representations found in the universe, but these are the most basic, found in a supernova and hydrogen atom, which is the first element on the periodic table. Also in 2014, scientists from the Harvard-Smithsonian Center for Astrophysics announced that they found a faint signal in the cosmic microwave background that could be the first direct evidence of gravitational waves, according to space.com. Then in September of 2015, the observance of the gravitational waves at LIGO made for exciting news. Scientists are one step closer to finding the elusive graviton, a particle that mediates the force of gravity. My hypothesis is that, like the graviton that has not been viewed directly, there is a particle that is found in nature that mediates the cosmological constant force, an anti-gravity particle. For the purposes of this paper, we can call it a lambda-on, a hypothetical particle named after the Greek symbol lambda, after the cosmological constant. These forces, in particle forms, could be used again in a ratio-type format of each other. Another hypothesis for a possible grand unifying theory point is the lambda/g force that could aid in some observations of nuclear explosions uniting the other fundamental forces, such as weak nuclear force. The electroweak epoch was the period in the evolution of the early universe when the temperature of the universe had fallen enough that the strong force separated from the electroweak interaction by partnering with the weak and strong nuclear forces, according to Wikipedia. Before this epoch in inflationary cosmology, the gravity/lambda binary constant could have been intertwined as part of the space-time together in early inflationary cosmology. Although there are disagreements of time periods between myself and the cosmological community, in this instance I would generally agree on how the four fundamental forces were created, specifically in reference to high heat levels. According to Wikipedia, the electroweak force responsible for the quark epoch in the early universe of 246 giga-electronvolts would merge into the single electroweak force. In high heat realms in the early universe, some types of forces were created and separated into the ones we see today. Although not all mergers of particles and forces are caused by heat, the electroweak epoch most likely was. The lambda part of the equation relates to the weak nuclear force and the W-boson nuclear reactions in such a way that W-boson charge induces an electron or positron emission or absorption, thus causing nuclear transmutation. Wikipedia. That said, nuclear transmutation could have within it the gravity/lambda binary constant, which is what is observed in the areas of space of large supernova and in the furnaces of the sun that are responsible for nuclear explosions. The gravity side of the equation, gravity/lambda, could be partially unified to what cosmologists name the strong force, keeping particles together like what is observed in planetary bodies and most stars in classical mechanics. However, gravity at the quantum level, holding the constituents of matter together, has no direct evidence to support. In large areas of mass, the gravitational pull is large. A conceptual picture of the strong nuclear force as a bonding agent could be replaced with a string theory-like concept of patterns of vibrations, interlocking to form collections of particles. This superstring postulate could replace or be contemporaneously accepted with the current concept of gluons bonding particles together. Clearly, turning dry cement through a process of hydration into a bonded set of particles by using strictly water is not the strong interaction, gluons or gravity at work. Different materials have different bonding agents, creating the plethora of bonds in the universe. My third hypothesis is that the combination of lambda and g as a reaction of mass is what ripples and curves spacetime that Einstein so eloquently wrote his general theory of relativity on. It both pushes outward and pulls around space, giving it curvature. When they observed a star that was behind the sun during a solar eclipse in 1919, it was partially because of the lambda force pushing the light outward and around the sun to the observing party, giving proof of Einstein's assertion that mass curves spacetime. This same force is in and has always been in existence.